morning, students. I'm Krishna Rao, Assistant Professor in CSE Department. I'm handling the compiler design for the 5th semester. So, in the last class, we have discussed the predictive parsing method. There is one more concept, that is LL1 grammars. Right? So, in the top-down parsing method, in the predictive parsing method, there is a LL1 grammars. Now we'll discuss in this class, we'll discuss the LL1 grammars. Here, a grammar is said to be LL1 grammar. To apply the predictive parsing methodology, there is a condition. Now we'll discuss what is the conditions and which grammar is said to be LL1 grammar. Here, the main aim is to remove the ambiguity in the predictive parsing method. So here, in the predictive parsing method, previously we have discussed, in that method, some row and column may have multiple entries. In the predictive parsing table, some row and column combination may have multiple entries. So, which leads to ambiguity. So, we must eliminate that ambiguity. So, we check the gamma is a giving ambiguity and not unambiguity. Then we say the grammar is said to be LL1 grammars. It eliminates the ambiguity in the predictive parsing table. Here, this LL1 parsing, the name indicates that the first L means scanning the input. The first L means scanning the input from left to right. The first L means scanning input from left to right. Right? The first L in the name LL1 grammar, it indicates left to right. The second L means leftmost derivation. Second L means leftmost derivation. Right? The name LL1 grammar, in that the first L indicates scanning the input from left to right. Second L means leftmost derivation. Then the 1 stands for using one input symbol for look ahead. It will consider next one input symbol for the parsing. So, this is the name indicates LL1 grammars. Here, the first condition, if A is giving two productions, alpha and beta. Here, A is a production which has two alternative productions, alpha and beta. Then, first condition, first of alpha intersection first of beta should be 5. Means the alpha production and beta production should not start with the same symbol. There is no terminal A which derives from alpha and also from beta. That is the first condition. Right? The first of alpha and the first of beta should not have any common L terminals. So, first of alpha intersection first of beta should be 5. That is the first condition. Here, if one of these two productions might be epsilon, both should not be epsilon, but one of them might be epsilon. In such case, If alpha is a epsilon, if alpha is a epsilon, then first of beta intersection fall of A should be 5. First of beta intersection fall of A should be 5. Both should not derive the same terminal. For example, if beta has epsilon, beta implies epsilon, which says first of alpha intersection fall of A should be 5. If beta implies epsilon, if beta implies epsilon, then first of alpha intersection fall of A should be 5. If alpha implies epsilon, then first of beta. If alpha implies epsilon, then first of beta intersection fall of A should be 5. So these are the two conditions. If these two conditions are satisfied, then we say the grammar is LL1 grammar, which results the predictive passing table will be unambiguous. There will be one and only one entries in each terminal and non-terminal combination cells. Right? Now we'll see the example. Here, this is the given one grammar. Now, we consider the first of variables. Then we have to consider follow of the variables. From that, we have to consider predictive passing table. If any entries are double, then we say it is not LL1 grammar. Here, first of S is I gamma A. First of S dash is E n epsilon. Then first of B is B. Then follow of S is E and dollar. Then follow of S dash is E and dollar. Here for the first and second, for the variable as I intersection A is 5. I intersection A is 5. Satisfies the condition. But if we consider here E and epsilon giving 5. E and epsilon giving 5. So first condition is satisfied. But one of them is epsilon. In such case, what we have to check? Intersection of E and follow of S dash we have to consider, which says E and dollar not equal to 5. Therefore, it is not LL1 grammar. Right? Since one production of S dash is epsilon, then we have to consider the intersection of the other production and follow of S dash. We have to find, which leads the E as the common one. Then simply we can say it is not LL1. Then also we check in construction of this table. So what happening here? As for the first production, we have written here first production in the I symbol, and for second production we written in the A terminal. Then for the third production, this is third production, but when you consider the fourth production, it has resulting multiple entries in combination of S and E. S dash and E. If we consider fourth production, which results into multiple entries in the passing table for the combination of the variable S dash and terminal E, which results a ambiguous. So in deriving the strings by parser will give multiple derivations which leads the errors, right? Then finally for fifth production, simply E gives, in the B we write B. Since if the third production and fourth production resulting, the grammar is not LL1 grammar, right? We'll see one more example. Here LL1 or not. Check here LL1 or not. This is a given grammar. We want to check this is a LL1 or not. This grammar has only the variable as has two entries, right? This one and this one. We want to check it leads to any ambiguous or not, right? We want to check this one. What happened? Now, for the first production, first of A is epsilon. So, simply first of A minus epsilon union with first of the remaining symbol which leads to A. So, the first production which leads to symbol A. Then, from the second production, first of B minus epsilon, since B gives epsilon, then first of BBA which leads to B. Which leads to B. Since A intersection B is 5, then we say this grammar is LL1 grammar. And the predictive passing table is unambiguous. Right? Now we'll see. What is the first of S? Simply AB. First of A is epsilon. First of B is also epsilon. Then, since epsilon in this grammar, we must consider follow of the variables. Right? Then, follow of S will be the dollar sign. A occurs in two places. So, this both symbol are considered as follow of A. Then, B at two places. Then, this both are considered as follow of B as B comma A, right? So, follow of A is AB, follow of B is AB. Now, for the first production, it giving A, we are writing the first production. For the second production, it is giving B. For the second production, here we have 10, it is a B. So, we write second production. Then, for the third production, it is epsilon. Since it is epsilon, we considered follow of A. The follow of A is, follow of A we considered A comma B. So, in both, we write the third production. We write the third production. Then, for the fourth production, since it is epsilon, we consider the follow of B. Since it is a follow of B, simply we write here. In both A and B columns, we write the fourth production. So, this is a LL1 grammar. So, this is LL1 grammar and this is a predictive passing table. Right? Here is one more example. Here it is one more example. Now we want to check this grammar is LL1 or not. Which productions have multiple production? S and A. S and A has multiple productions. Right? So we have to consider S and A to check the both results the LL1 conditions satisfied or not. So here first of S this one. So we considered first of 1AB union with intersection with first of epsilon. So condition 1 is satisfied. But since it is epsilon, we must check first of 1AB and follow of S. Since one production is epsilon, then we consider intersection of the first of other production with the follow of S, which is 1 and dollar. So second condition also satisfied. Then we consider 1 AAC slash 0C. So here it is once again giving 5. Once again it is giving 5. So finally it is LL1 grammar. So it is the LL1 grammar. It satisfies both the conditions. So simply we can conclude it is LL1. Then the next step to find out the first of all the variables, then find the follow of the all the variables, then find simply write down the predictive parsing table. Right? Here first of S 1 from the first production, epsilon from the second production, 1, 2, 3, 4, 5, 6. Right? From the first production, it is 1. From the second production, it is epsilon. Then, first of it. From the third production, it is a 1. From the fourth production, it is 0. Then, first of B is 0. From the fifth production. From the sixth production, first of C is 1. First of C is 1. Here first of S equal to 1 comma epsilon from the first 1 and 2 productions. First of A is 1 comma 0 from the third and fourth productions. From the fifth production it is 0. From the sixth production it is 1. Then follow of S equal to $sign. S is present in any other productions. We have to consider here it is S. So follow B. So follow B once again, which results to the $sign. Right? Here follow B is follow of S, simply $sign. So follow of S and follow B gives only $sign. Then follow of A. From the first production, it is first of B. From the third production, it is first of C. Right? First of B is, what is the first of B? It is 0. Right? Then, what is the first of C? It is 1. So, follow of A is first of B from the first production, union with first of C from the third production, which is to 0 comma 1. Then finally follow of C. So follow of C is present in third and fourth production, which results both to the follow of A, which is simply 0, 1. Now first production we write in the 1. For the second production, we have to consider follow of S. What is the second production? Epsilon. Since it is epsilon, we have to consider follow of S. So here this is the second prediction. Follow of is dollar sign. In the dollar sign, we have written S gives epsilon. Right? Then A. Next, third prediction. From the third prediction, it is 1. So we write third prediction 1. For the fourth prediction, it is 0. We write fourth prediction. For the fourth prediction, it is 0. We write fourth prediction. Then, for the fifth prediction, it is 0. B gives 0 as fifth prediction. So, B and 0, we write fifth prediction. Then, finally, sixth prediction. Here, the sixth prediction, C gives 1. So, C comma 1, we write as sixth prediction. Right? The sixth prediction, which is a C and 1, which results to 0, 1 column, we write the sixth prediction. C implies 1. So, this is the completion of construction of the predictive passing table. And since the grammar is LL1, we already verified with the conditions. So, the predictive passing table is unambiguous. Right? Next comes to the error detection in the LL1 passing method. Here, they might be, we are specifying that all blank spaces in the predictive passing table are simply as errors. Every time, whenever an error occurred, whenever we are passing any programming, any error occurred, then the error message sent to programmer and it has to be rectified for each and every thing is a headache process. So, here, that error handler will try to handle some of the errors so that the passing will continue. The compilation process will not be stopped. We associate each empty slot in the predictive passing table with some error handling step. So that is we called as phase level recovery. That is, one is phase level recovery, second one is panic mode recovery. Right? Phase level recovery says that each empty slot in the predictive passing table will be associated with some error handling steps so that it will be rectified and it will be continued the passing. Then another one is panic mode recovery. This panic mode recovery says that modify the stack or modify the input string by deleting some terminals or adding some terminals such that it will reach an appropriate state and it will continue the passing method. Right? So modify the stack or and some input string. Try to reach some state so that which can continue the passing of the remaining input string. So the phase level recovery, panic mode recovery. Here, panic mode recovery says it decides some set of synchronizing tokens. Means it will consider some possible type of errors. Missing semicolon, missing commas, missing parentheses, missing all such type of possible errors will be considered. So, adding them or deleting them, it will be rectifies the error. So, when an error is found and there is a non-terminal at the top of the stack, simply discard the input tokens until synchronizing token is found. So, if a non-terminal on the top of the stack. Then discard the input tokens until the respective token is formed. The synchronizing tokens are chosen so that the parser can recover quickly after one is formed. Right? Semicolon when passing statements. Example, a semicolon. Right? When passing the statements. If there is a terminal on the top of the stack, could try to popping it to see whether we can continue. Assume that input string is actually missing the terminal. Right? So, if the stack has a non-terminal on the tab, skip the input symbols till it find the respective synchronizing token. Right? If terminal on the top of the stack, simply pop the terminal. Consider that the symbol is missed in the input. Right? Here, possible synchronizing tokens for non-terminal A. The tokens in follow of A. When one is found, pop A of the stack and try to continue. If the tokens in first of A, when one is found, match it and try to continue. Right? So, if the token is found in follow of A, simply pop A and try to continue. If the token is found in first of A, simply match it and try to continue. So, tokens such as semicolons that terminate the statements. Right? So, here, this is a passing table. Previously, we have considered. We are specifying the blank spaces as errors previously. Now, we adding here synchronize. Like possible options here we are writing. In the blank spaces, we are specifying it can be synchronized. Here, we have done some mistake in the typing mistakes. Here, the parenthesis is additionally added. ID is missed. Actually, ID into ID plus ID is the input string. But mistakenly we have typed. So, here E and parenthesis. What we have E and parenthesis, simply synchronize. Simply skip the one. Then E and ID, we have E gives T dash. We have written T dash. We will continue these steps later with FT dash, then ID, then we remove ID. Now what we have, here it is a T dash, here is a multiplication. T dash and multiplication, what it's saying? Synchronize. Right? So, simply we says, we considering the step. We remove this one and we replace with it's a production multiplication FT dash. Right? Here, T dash in multiplication. Right? T dash with multiplication, synchronize. So, here, simply, we continued this one. Right? FT dash, then we remove this multiplication. Simply we remove the multiplication. Then F, and here ID is missed. So F plus, we are checking F and plus, here synchronize. The F here is missed. F and is synchronized. This is T dash here. This is F. Okay. So, right, this is T dash, right, this is F column. Okay. So, T dash multiplication F dash, simply V t dash is replaced with multiplication f t dash. This multiplication is removed. Then fn plus. Here, this fn plus, we are indicating the synchronize. Fn plus indicate the synchronize. Right? It's a giving other. So simply we pop this multi f and we continue with the t dash and plus. Right? We continue with t dash and plus, and we continue the steps to complete the passing. Right? This is an example for panic mode. So whenever they are typing errors, we'll consider some possible typing errors and we'll specify skipping the input symbols or skipping the respective stack symbol so that the passing will be continued. So I'm closing this section for today and we'll continue the remaining topics in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.